Introduction. Definition of hydrodynamic. A branch of physics that deals with the motion of fluids and e-force acting on soil bodies immersed in fluids and in motion. Flow visualization. Used to make the flow patterns visible. In order to get qualitative or quantitative information on them. Dye injection method, oil flame method, hydrogen bubble technique, streamlines. 5.2 Real and ideal fluid. 5.3 Classification of fluid flow. In uniform flow, flow conditions are velocity, pressure, cross-section, or depth are the same at every point in the fluid. Non-uniform flow. Flow conditions are not the same at every point. Steady flow. Flow conditions may differ from point to point but don't change with time. Unsteady flow. 5.4 Compressible or incompressible flow. 5.5 Behavior or fluids in pipe. A. Lamin. B. Transaction. C. Turbulent.
The type of flow is an important factor when considering energy loss within the hydraulic circuit. There are two different types of flow, laminar flow and turbulent flow. The type of flow may be determined using Reynolds number. Reynolds number is dependent on the velocity of the flow, viscosity of a liquid, and the cross-sectional area through which the water flows occurs. Liquid from the tank enters the transparent pipe. The flow rate is regulated by the valve. The ink enters the center of the pipe to a thin tube. Up to a certain velocity, liquid moves along the pipe in layers. The innermost liquid layer at the pipe surface does not move. This is the laminar flow. If the velocity flows is increased at a clinical velocity, the type of flow changes from laminar flow to turbulent. When open the valve more, the flow through the pipe will increase. The flow becomes whirling, the flow resistance increases, and thus the hydraulic losses increases. This is the turbulent flow. Turbulent flow is not usually desirable because the flow resistance increases and the hydraulic losses increases too.
Okay, this is defined Egan-Poiseuille's equation. So that for laminar flow, the pipe 8 loss by friction HR represented by HF equals to 32 UVN over PGD square. So where U define dynamic viscosity, the unit is Newton second per meter square, and the V average flow of velocity, the unit is meter second. L represent pipe length in meter. P fluid density kilogram per meter cube, and G acceleration due to gravity meter second square. D defines diameter of pipe in meter. So that loss of pressure 8. The method is HF equals to P1 minus P2 divide PG. Difference of pressure or P1 minus P2 for viscous or laminar flow is given by P1 minus P2 divide PG equals to HR equals to 32 UVL per PGD square. The Reynolds number is less than 200. RE equals to PVD over U.
This is example 7.2. For this question, we will use the formula HR equals to 4FL V square over 2GD. So for the L, we will use 400 meter. That is been given up here. And then for the diameter is 0.15 meter. And for the velocity is 1.4. And the friction is 0.01. So we will write down all of the given information of above and then just in place that in the formula. So if you can see 4 times 0.01 times 400 times 1.4 square over 2 times 9.81 times 0.5, and then the answer is 10.656 meters, and that's all.
Okay, Assalamualaikum dan selamat pagi. Hari ini saya akan menerangkan tentang cara untuk tutorial untuk membuat soalan loss of heat bagi pipe. Okay, first, jadi kita akan buat untuk soalan 3, iaitu the discharge through a pipe is total 200 liters per second, and the loss of heat when the pipe is suddenly enlarged from 150 mm to 300 mm diameter. Okay, jadi dia bagi kat sini diameter untuk yang diameter 1 dan diameter 2. Jadi kita kena convertkan semua tu kepada meter dahulu. Jadi dia dapat, jadi kita akan dapat bagi, dan jadi dia akan dapat R dia dapat lebih kurang dalam 0.075 meter. Okay, bagi R2 pula kita dapat dalam 0.15 meter. Okay, kemudian untuk discharge pula kita kena convert pada meter padu per second. Jadi kita dapat 0.2. Okay, jadi kita pergi area dia, jadi pi R 0.2. Jadi dapat macam ni lah. Area 1 dapat 0.018, area 2 dapat 0.071. Okay, kemudian flow rate, kita kena kira flow rate pula. Formula flow rate ialah Q sama dengan VA, iaitu V velocity, A area. Jadi velocity 1 dapat 0.2 bagi 0.018 dapat 11.11 meter per second. Bagi V2 pula 0.2 bagi 0.071 sama dengan 2.82 meter per second. Okey, dah dapat semua tu, jadi kita masukkan dalam formula. Okey, jadi heat loss. Jadi HL sama dengan V1 tolak V2 square per 2G. Okay, 2G itu gravity. Jadi V1 tadi kita dapat 11.11 tolak 2.82 kos 2 per 2 9.81. Dan okey, masukkan guna kalkulator untuk kira. Jadi kita dapat 3.503 meter. Okey, itu saja dari saya. Okey, terima kasih.
In this lesson, we will discuss how to calculate the minor losses in pipe systems. In a previous video, we examined the major losses in a pipe system, which are denoted by HL major and are caused by viscous effects in straight pipes. This video will discuss the minor losses, which are denoted as HL minor and are caused by viscous effects in pipe components. Before we begin, it should be noted that the subscript minor does not mean that the minor losses are always less than the major losses. There are many pipe systems in which HL minor is greater than HL major. In general, components affect the flow by changing the direction of flow, obstructing the flow, and changing flow speed through varying the cross-sectional area of the pipe system. Pipe systems may have many components. Bends, elbows, and T's are devices that change the flow direction. Valves are used to adjust flow rates. Expansions and contractions are used to slow down or speed up the flow and may occur suddenly or gradually. Entrances into pipe systems from reservoirs and exits from pipe systems into reservoirs are also considered to be components. Many components, such as the elbow, bend, sudden contraction, and sudden expansion shown here cause the flow to change direction rapidly. This can lead to regions of separated flow, shown in blue, where eddies are formed. The presence of separated flow regions can greatly enhance losses in components.
Application of fluid flow. Fluid flow is a part of fluid mechanics and deals with fluid dynamics. It involves the motion of a fluid subjected to unbalanced forces. This motion continues as long as unbalanced forces are applied. For example of the application in life and use, if you are pouring water from a mug, the velocity of water is very high over the lip, moderately high approaching the lip, and very low at the bottom of the mug. The unbalanced force is gravity, and the flow continues as long as the water is available and the mug is tilted.
Major losses are associated with frictional energy loss that is caused by the viscous effects of the fluid and roughness of the pipe wall. Major losses also create a pressure drop along the pipe since the pressure must work to overcome the frictional resistance. In order to determine the major losses in pipe, the Darcy-Weisbach equation is the most widely accepted formula for determining the major loss in pipe. In engineering applications, it is important to increase pipe productivity, maximizing the flow rate capacity and minimizing head loss per unit length. The design tools that is used to help determine head loss are associated to rip currents that can be represented by a written flow characteristic curve, and the relation between piling up and net mass flux across the structure can be similarly described by a barrier pumping curve.